Welcome back to An Introduction to Cognition. This course is found at blogs.umbc.ca/cognition. Module 1.2 focuses in on a brief history of cognition. Before we begin, let's outline the 3 learning outcomes for this module. In terms of knowledge, we want you to be able to list and discuss the key people and events that contributed to the rise of cognitive psychology. You're going to use your research skills to figure out who those people and events were and why they were significant. And that's the last part, the valuing part. We want you to express why these events were significant. Why is it important for us to look at our past before we look at the future? Here's a quick overview of where we're going in this module. We're going to be looking at the pillars of psychology and a brief history as they relate to the development of cognitive psychology. We'll look at challenges to behaviorism, the early influences on cognition, and some recent metaphors that have helped shape our thinking with respect to cognitive psychology. As a reminder, the central idea in the first module is that the human mind, and in particular our mental processes and structures, can be scientifically studied. So let's begin with the 3 pillars of psychology. Psychology did not evolve out of a vacuum. There were 3 essential pillars that helped build psychology. One of those pillars, the longest standing pillar, was philosophy. From the time of Aristotle to today, philosophers have helped shape the scope and discipline of psychology. They've been interested in the concepts of the mind, and in particular how we store and represent information. They've also been interested in topics such as emotion and how it relates to our thinking. Another very important area that dates back as far as the philosophers is medicine. We've always been interested in what this thing in our head does. For some, it was a cooling mechanism. For others, it was the source of this thing that we call the mind and our mental processes and structures. The other component that led to the development of psychology was the scientific revolution that occurred from about 1550 to the 1700s. Those 3 components, philosophy, medicine, and science, all led to the emergence of what we would call psychology today. A brief history of cognition. The subfields of psychophysics, structuralism, functionalism, behaviorism all played an important role in the development of cognition. Some of them had positive influences, others had cognition arose as a reaction to. Throughout this week's homework assignment, we will be focusing more in depth in terms of the contributions of the psychophysicists, the structuralists, functionalism, and behaviorism. We'll also look at their strengths and weaknesses and where their contributions have been made to cognition. So please look at the homework assignment that is posted on the website, on the blog site now. One of the major schools of psychology that has had an impact, sometimes direct and sometimes indirect impact on cognitive psychology, has been the field of behaviorism. Folks like Pavlov, Skinner, Watson, and several others contributed to the development and growth of this area before the 1930s through the 1960s. But there were several challenges that were raised about behaviorism, and we'll explore a couple of those in a few moments. First is that organisms, humans, rats, other animals, tended to misbehave. They didn't behave the way behaviorists thought they should behave. So there are a couple of examples. One we'll explore in a moment is mental maps with rats and infant attachment theory. There are other influences, such as World War II. what we find in World War II are many examples where the behaviorist predictions begin to break down in practice. So there are many practical examples as well as the theoretical examples of organisms misbehaving, and also some really interesting and great debates that occurred in the late 50s, early 60s. For example, the linguistics debate with Chomsky and Skinner. Those challenges began to lead us to think about a different analogy about how the mind operates. And that, we'll get to in a moment, opens up the mind for exploration. So let's look at the ways in which rats sometimes misbehave. Tolman's classic article, Cognitive Maps in Rats and Men, which you can find freely available on the internet, highlights some of the ways in which the rats did not follow some of the behaviorist predictions. So for example, let's have our rats start at the start box, and their job is to get to the food box as quickly and efficiently as possible. With no roadblocks, they're going to take path number 1, straight from the start box to the food box. However, if we put a roadblock in at point number A, both the cognitive and the behaviorist approach would predict that the rats would hit that roadblock, come back to the choice point, and then take path number 2 around the roadblock to go to the food box. And it turns out that the rats did that. So that's not the interesting component here. We know that the rats are going to take path number 2. However, if we put another roadblock in place, roadblock B, what the behaviorists would predict is that the rats would again take path number 2, find out that path that route is blocked at point B, and then return, and then finally take path number 3. However, what was shown was that the rat selected path number 3 on the first trial over 90% of the time. They didn't take path number 2, illustrating that the rats had a cognitive map or understanding of the routes and different pathways from the start to the food box. And it's not just animals that misbehave, it's us humans. Well, we are animals as well. Behaviorist theory failed to predict accurately some of the complex interactive behaviors that we see. For example, infant attachment theory. Children who are more securely attached to their parents early on in life aren't holding on to their parents' apron strings later on in life. They're actually quite independent. They can be quite independent from their parents. So that was one crossover type of interaction that couldn't be predicted at the time by behaviorism. Nor can it account for some of the behavior-thought control relationships. You've probably experienced this 1 or 2 times in your life. I know I have. So tonight, try thinking about going to sleep. Think about sleep as you're falling asleep and see if you actually sleep. The theory of ironic processes suggests that the more that we think about sleep, the less likely we will fall asleep within those moments. What we're doing is we're updating, we're checking our system. Have we fallen asleep yet? No. Okay. Have we fallen asleep now? No, we haven't. And by doing that, we keep thinking and we stay awake. So we've discussed the pillars and foundation of cognitive psychology from a historical perspective. We've looked at cognition as a reaction to some of the challenges found with behaviorism. And now we're going to look at some early influences on cognition. Just like any area of thinking, we often have an analogy out there that we rely on to help solidify our understanding of a particular topic. So the same was true with the development of cognitive psychology. The computer served as a nice metaphor. So the physical computer was something that could learn to some degree. It stored information, it manipulated information, and it held that information in memory. It had internal components in processing. It also had flow diagrams, and those flow diagrams were very useful to help map out what we thought might be happening in the mind. Today, we've advanced our thinking about an analogy with respect to the mind to not just the physical computer, but the types of software that might be on that computer. And we'll talk about that a little bit later. Linguistics, the shift from the behaviorist accounts to or theories that emphasize structure, underlying comprehension. And here is the influence again of Chomsky, 1957, his book Syntactic Structures was key. And developmental psychology, Piaget emphasized cognitive structures, internal structures and processes with respect to human development. Technology and the advent of new technology has a way of impacting society and also the way we think about things. And so was the case with the advent of the computer in the late 1950s. It provided a new model for thinking about the mind and how the mind operated. So let's explore that in a little more detail here. The computer has a keyboard. With that keyboard, we can input information. Now, what we see on a keyboard is a bunch of letters and numbers and symbols, backspaces and delete keys. But that's not what the internal system sees. The internal system relies on a series of electrical signals and binary code. That is the information that it works with. So notice we've gone from letter symbols on our keyboard now to electrical symbols and binary code. So something has changed there in the process. That information that is now internal gets processed. It gets stored. It'll sometimes get manipulated, added to other things. We'll use it for problem solving, etc. So then that information, at some point we want to retrieve it, so we'll look it up, we'll bring it back, and we'll display it, sometimes on the computer monitor, or we might output it to a printer. Metaphors for information processing. There are a couple main models for thinking about cognitive processing. We can take the computer metaphor approach and talk about information processing. Information flows from this system, gets processed in that particular system, moves on to another system, goes from that system into another system, etc. So we'll talk about box and arrow models and highlight a couple of them throughout this course. We'll also be talking about the brain metaphor, and in particular, borrowing from biology and neurology, our understanding of how neurons operate, and we'll use that as a metaphor for exploring information processing. So let's look at the computer metaphor, and in particular, the information processing models of how the mind might work. These models tend to be box and arrow models, or explanations of how the mind might work. For example, in this diagram, it's the Atkinson and Shiffrin model, the original model for memory that we had. What they suggest is that we took in information into short-term memory, that information could then be stored in long-term memory. It got transferred over to long-term memory. At some other point in time, we would transfer it back and retrieve it back into short-term memory. But also with short-term memory, we know that there's a decay component, or displacement. So information sometimes gets lost in that short-term memory system. So here is one explanation of how memory might work. There are general comparison between the computer and the mind in these information processing theories or accounts or models. There are general processors. For example, we've got general processors related to math, language, drawing, etc. Information needs to be translated into different formats, and there's a capacity to store programs, instructions, and the data that we're working with. All theories, models, ideas about how the mind works are based upon assumptions. And the information processing account is no different. So here are some of the assumptions associated with the information processing model. First, cognition is best understood by analyzing it into a series of mostly sequential stages. Each stage, input, recall from long-term memory, decision, output, requires a unique process, and each stage works on its own set of internal representations. Before we explore the second metaphor, the brain metaphor and connectionism in more detail, we need to make a contrast between what computers can do and what the human mind can actually do. So for example, humans can quickly figure out variations in patterns. For example, all of these different A's, we quickly recognize them as the same letter. Computers can do error-free calculations. I can't. Can you? Humans speed up their processing. So for example, are you faster to provide an answer to the problem 2 times 6 after seeing it many times? Quite likely you will be. MacLeod, Plunkett and Rawls, 1998, in their book, An Introduction to Connectionist Modeling of Cognitive Processes, talk about 5 biological principles that they think are embodied in the connectionist approach to thinking about cognition. So for example, we know that neurons integrate information. They collect information from other neurons. They then pass information about the level of their input, whether a specific threshold has been reached or not. Brain structure tends to be layered. The influence of one neuron on another depends on the strength of the connection between the 2 neurons. And learning is achieved by changing the strengths or the weights of the connections between the neurons. So with this very general introduction to the history of psychology as a discipline, to cognition as a subfield within psychology, and to some of the ways in which cognitive psychologists think about mental processes and structures in terms of the information processing approach and the connectionist approach, we're now ready to explore the types of tools that cognitive psychologists use to study the mind. So join me for Module 1.3, where we'll explore cognitive methods.